My name is Sebastian Zając, and I will present for you something called Julia in production environments. Because it's our first day, I will try take some resume of our course. Maybe not how it's really look like, but how I see this course, and you will see what for me was important and how this is connected with production environments. In our course, you can check that we show you. Okay, we start from the team of people who show you different cases in Julia programming, especially how you can use Julia programming language to the data science process problems, and why it is so. Maybe you can find information that this Julia language is strictly connected with some mathematical computation, some optimization problems, and data science. But of course, it is a ordinary programming language, so you can use it to do something more than just data science. And if you look at our teams and our codes, you can find that so simply information that all our codes are in a GitHub repository. So I can ask, why GitHub repository? Of course, because it's easy, but there is some hide information in this because we work in team. GitHub gave us possibility to take our codes for everyone. This is and for everyone in our team could quickly pull, push, and reproduce all codes and load all codes in your computers, in our computers for work. So this is kinds of working stuff with exactly not only production, but also a developer environment. So GitHub will be first tools which you should use when you want to do something not only in data science, but also in any programming language. In our GitHub, you can find that we show you some lower codes on strictly programming. Meaning that's what I mean by this is that in Julia, like in other language, we have some variables. You can put some for these variables, you can put some numbers, some strings, and you can define some functionality, and more you can use more of than this. You should know what is how to define a flow of your program and how to use loop, or sometimes what could be better if you use loop or if you doesn't use. And this was part of the beginning. So this was strictly connected to show not only that Julia has this possibility, but and it works fast, but also to show you that in this language you can do not only things connected with data science. So ordinary scripts like in Python script, Bash script, you can also do it on the Julia. What was also important, but maybe obvious, that in each lecture we try show you how to start a Julia environment. On this environment, you activate our project, and after that you activate, of course, Jupyter Notebook. But if we miss this step with Jupyter Notebook, you see that it is important to know how to start Julia environment in your personal computer and how to work on RAIP or in console. Why it is important? Because in many cases, we need know how to run this environment in not only in our computers to work, but also in some other environments, like in production environments, which could be other computers, other servers, other any device you want to run these processes. After that, we show you that why I speak about this, because I heard and you can probably read a lot of questions that I want to start with data science and what kind of language I should use and what kind of language I should learn to get fast, to be great data scientist. In my opinion, you should learn programming, not just any kinds of languages, because if you know standard way of thinking in programming, you will get fast thinking in any kinds of programming language. So of course, there are in the different kinds of languages, there are some tricky differences, but if you want just to put your knowledge and work on the data science, I think that knowledge connected with ordinary programming, like what is flow, how to do flow of your program, how to do loops, where loops is good, where loops is not good, and ordinary what is sort, how sort is looks like, how it's work, it is fast or not. So I think that there is no answer like you should use Julia. Of course, in our team, we use Julia. But you should start with programming concept and it will be help for you that you can run and write your program in any environments and programming language. I can say that one difficult could you find on something called SAS language, because it's for GL language and it has more complicated thinking. But of course, if you ask yourself, if I start with Julia or Python or R, it doesn't matter. This lecture should show you that, because we should thinking about production environments, this presentation should show you that you cannot be connected and strictly do things in one language, and why I will try to show you in this lecture. After some basics on Julia programming, like in other programmings, we do a lot of stuff connected with tabular data and how to proceed this data. This is also very important because most of the processes in data science are not putting a models and find great model, but most of them and most of work is connected with preparing and change your data to usable form. Yes, because if you have usable form, it is easy to apply any modeling. Of course, in our lecture, we try do a quickly review of how to use some kinds of models, and we are not do a lot of ETL processes and create new variable or this kinds of stuff, but I just remark you that it is very, very important also in data scientist work. And after that, we show you not only tabular data, but also graph data and how to do these kinds of data in modeling in Julia. We also show you by Przemysław that you can use what was very nice for me, because you can use Julia to the optimization processes, which of course, are hard processes for thinking, like to do some kind of machine learning and deep learning modeling. But what was nice and what you should find in these kinds of lectures, it was that you can use Julia like not ordinary programming language with stuff in this kinds of language, but you can use you can write your every code like mathematical formulas. So this is very nice because it's simplify your code. You know what you want to do, and you don't think how I must change my mathematical code to the programming code. And in Julia, this is easier than in other kinds of languages, for example, like in Python. And today I will try show you that all of these kinds of programming stuff we show you, it's not enough today for data scientists. And also, I just missed one thing, that we show you also theoretical aspects of modeling. It was, in my opinion, it was also very important, because it cannot be that you just think that data scientist work is just take data, put to the automative program and get some models. Sometimes you put a hyper optimization processes to get better model. If just remember that there is a very famous short that garbage in give you garbage out. So the reasoning why we show you theoretical aspects is also very important in this work. Okay, so okay. So this is how I see this short resume of our course. So because I want to show you how to use Julia and that we can use Julia in a production environment, we must take feeling what production environment is. And this is more connected with, so we will start from business case. So let's assume that we work for some companies that sell apartments here in Boston. And we want, as all companies, we want increase our sales and offer better quality service to our customers by putting our service to the mobile application, which our clients could be used on mobile, on tablet, on PC, on everywhere when you could run some web browser. And of course, our application should work not only for one device, but it should work for many devices. It shouldn't be difference between working for 100,000 of devices at one time, or even 1 million devices of one time. So you see that this scale, it should be this services should be scalable so we should think about this, how many applications we can run simultaneously in our case. Okay, so what is the solution? If I ask you what kind of application you use mostly on your computers, you can say, okay, this is some kinds of operating system. But today, you can, because we have a connection to the internet, you can see that most cases when you use your computer is not connected with any special kinds of application, but there is just one application. It is web browser. Why? Because it's a very simple run, and it's very simple put everything on the web page with text, with pictures, with movies, and very easy way to change colors, change shapes, and do everything on the web page. And so this is in my opinion just natural. You know that at present we can buy everything by web browser. We can even play in games in web browser. We do check our email, so we don't have any kinds of application that do something in our computer. We put everything to the web browser. So we can use it for our application in our business case, and we can realize this case by serving a prediction of house value when the user sent a request for us, and a request will be connected with pricing over the web. So so pictorially, we have a lot of customers which are used our app, and our app is connected by internet to the some server. It could be server on like a hard computer, and but of course it could be cloud at present environments when you can produce a lot of virtual machines, virtual computers, and these kinds of computer cloud could be also used. So for our so we have model and we want reproduce it and want that it will be work for us. So our model will give us a prediction for some values. So in our server, we will run a machine learning model that is trained to predict house price based on some features. Of course, the features are strictly connected with tabular data, and we will use this famous housing database connected to the UCI repository. Okay, but so in here you can say, okay, what in our course, what we have done with to get a machine learning model, because in here we can say that, okay, the most problem is how to get machine learning model. Okay, so one solution could be, let's take our Julia environment, like takes our Julia notebooks with our codes to generate some machine learning model and send it for everyone. Of course, it will be very, very not good thinking. Why? Because not everyone has environments prepared to run this code, to download our data, to proceed all stuff connected to the machine learning modeling. And of course, no one is interested how we get our model, and business in a high level, it not is interested how you get your model. If you get random tree or logistic regression, it doesn't matter. It must work. And if you want that your model should work, you must put it to the some environments. And this environments is called production environments. So here we have just technically simplified divide that we in our case what we show you, we can say that this is work how it's look like work on development environment, but there is huge difference between development times and putting our work, especially connected to the machine learning processes in production environment. Okay, so what exactly is serving a model? And this is also some process that could be optimized. It sounds maybe at the beginning strange, but if you realize that it is not so easy, just put your results to the production environment. So if you're training a good or bad or better model, it doesn't matter. So this is only the first part of your work, because you need to make your model available to your end users. And of course, you can do this by providing access to the model on your server or on your servers. So for serving machine learning or deep learning or what you kind of model you want, you need, of course, a model, but of course also an interpreter and some input data. And there is also a very important, because you have physical device called server, it is also important and optimizing kinds of thinking. Okay, how many servers we must have to realize our prediction for our customer? What is the cost of this server? What is the cost to get good model, and how good model we must have? And if we take maybe worst model but faster model, it will be faster. I mean that it get us faster solution. Maybe we don't need any kinds of machine learning model, but just some rules, typical rules, like if you have red car, put value this one. If you have blue car, you can get value this. So it doesn't matter if it's a machine learning model or just decision rules. You must rethink how to take this together. So important metrics for your serving a model is latency. It is time when how fast your server put your answer. It is, of course, a cost, and throughput, which is the number of requests served per unit time. So because, as you probably know, if they sometimes on the web we have happy hours or something like this, that okay, you want buy some tickets for something, I don't know, for some football games or for other kinds of things, and you think, okay, I go to the web browser, I put all information, I send this information, and oh no, I cannot buy this ticket because why? Because server is not response. Yeah, so from our so what you do, you of course, if you are fans of your team, football teams, you do it again. But of course, in our business case, you will just change application and remove our application. So from business point of view, if server not take these kinds of metrics, you lose your clients. So you lose your business. And the worst case is that sometimes servers will drop fully down. It is most bad case, because you lose your clients, not everything not working, your application not working, totally disaster for your business. So in this business case, you see that putting generate machine learning models or any kinds of modeling, it's not, for business point of view, it's it's just one little piece of full stuff of elements. Okay, but if we take this mechanism that we want to produce some application, this application will be easy. It will be sent just some request. This request will be produced as HTTP post kinds of request. I will show you on the notebooks how in Julia we can generate these kinds of stuff, and that this is very, very easy. But of course, we should produce some client application which send request to the server, and this server get for us response. We will use a typical JSON response and JSON to the input our data. Why JSON? Because it's strictly connected with key value kinds of dictionary. We can see JSON as a dictionary with key value, but of course JSON has some more properties that you can put JSON to the JSON, so you can put more information than just one value to the one key. Yes?
Yes, I have a question. So, because you said it's client application, like what could this client application be in practice?
Client application could be some part of codes that take information of the features and send these features to the, in our case, in case of machine learning modeling, you must send a row of data, yes, which you produce your model. So client application should be kinds of application that you put information and produce a row of data, and you send this row of data to the model, and model give you response that contain a prediction of your data. But of course, the application could be more complicated, because sometimes you can say, okay, but I don't want to send 30,000 of features, yes, to our application. So it could be that you have application that you send just some customer ID. This application take information from many databases and collect this information to the shape of your request, JSON request. So you produce this request beyond of the application, and of course this take a time. So this is not so easy how to do it, and in what kinds of maybe not what kind, but if we should take all information and send it to the server, or we should send to the server just simple information, and maybe the server should do something more than just put a prediction for you. Okay. But so server could be not just one application to get response, but it could be a full stack of microservices which work together, and if they work together, the last part is server response. Yes.
Okay, so in our application, this Boston housing, if I understand you correctly, is that in the simplest case, you could say, okay, I need to send, the size of my apartment, floor, etc., how many bedrooms it has, and this
okay.
is a simpler application. And this more advanced, if I understand you correctly, for example, you just on Google Maps go and put a pin, and you say the house is here, and then the server collects all the data and finds out in this very location what is the type of house, and then extracts the features. Yes, do I understand this distinction correctly?
Yes, exactly, because I will show exactly what kinds of info, what in our case, when we use this data for Boston houses, how we prepare this model and what kind of information we should send. Exactly, this I will show, and this we will construct on Julia. But of course, it in a real application, it doesn't have a sense that each user should put all our features to the web application. Yes, so of course you're thinking that we should take Google Maps pin and localization is very good, and of course client application could take this information and, as I said, prepare your raw data and put it to the server. So okay, so for our application we will be used so something called REST API. So in my opinion it is good. Maybe this is not correct fully informatics, but if you look for Python language, Julia language, R language, it is very good thinking about these kinds of languages as some kind of API. Why? Because if you're thinking about this as API, you know that if you want to do something, you must send, so you must produce some code to sending some information to your functionality on. It doesn't matter. It will be. We can say that data frames, maybe Bogumił will be not. It might be. It is not corrected, but I think that it's very good to say that data frames are kinds of API for data table analysis in Julia, and of course in many other kinds of languages. So if you see a languages as a kind of API, it's very easier see how it's all works.
Yes.
Yes.
So maybe let me just comment on the table. So sorry for those who are online, but so what Sebastian says is the following, that in Julia we have the following design. So there is a tables JL package, and this is an abstract concept of a table. It doesn't define any concrete table. It's like we say, it's a table. So table essentially says, okay, I have rows, I have columns, I know how to query it. But it doesn't specify a concrete technical way to implement it. So one of the implementations is data frames. JL. And data frames JL is the implementation that makes this abstraction real. And in data frames, the design is that we use a columnar storage model. Because going from here to here, the issue is that we ask ourselves, okay, I have an abstract concept of a table, but then in different use cases, if we want our operations to be fast, this abstract concept can be materialized in different ways. So for example, data frames is a way to materialize the concept of table in a way that we store data in columns, which means that data frames is very fast for operations like calculate me the mean of a column or calculate me a standard deviation of a column. In general, any query that asks for a column. But for example, data frames will be slower if I start asking about rows. So for example, okay, give me, of course, it's not super slow, but it's slower than asking about columns. There are other types of tables. So let me just give one example. So if I have a vector of named tuple, we have not discussed this in detail, but in general, I hope intuitively that you can feel that this is a vector of rows. So vector of named tuple would be, for example, A equals 1, B equals 2, A equals 3, B equals 4. So here we can see that this storage model is row oriented. So here it will be very easy to pick one row because this is row 1, this is row 2. But on the other hand, so it will be very fast to pick a row. But on the other hand, if I want to ask, okay, compute me the mean of column A, then it's more expensive because from each row I need to extract one element, and only then I can compute the mean. So in Julia, this is a very important concept that I have a general interface to any table, and then we have multiple tables optimized against different use cases. So here I discussed the column-oriented table and row-oriented table, but for example, we have tables specialized for time data. So if you have data that is temporal, and there are specific queries in time data, like for example, select me rows only from a given period of time, and I want this to be very fast, yet there is another type of table that is specialized for time. Another table type we have that is specialized for geospatial data. So if I have queries, for example, find me all objects that are close to a given map location. So all of them have some special features for which types of queries they are fast, but at the same time, they support the common operations. So this means that when I work with Julia and do common operations, I write them in the same way and do not have to care which actual implementation I use. But of course, if I know that, for example, I know working with geospatial data and want it to be fast, then I pick the right way to materialize this concept, and then I ensure that the queries that I would typically want to do on this specific type of table fit like specific to my use case, that this will be fast. And this is a very important difference of Julia versus, for example, Python, because this is possible only because Julia supports something that is called multiple dispatch. Yes, so we already discussed this, because here a function in tables says, give me any table, I don't care. And those specific tables, just using multiple dispatch, specialize different types of queries to be efficient on this type of specific object. So this is something that is maybe not unique to Julia, but unique to Julia as opposed to other standard languages used in data science. Because of course, there are other languages that also allow you to write this type-specific dispatch. For example, in C++, you could also write this. But in the realm of data science, Julia is quite specific here. And this is very useful because, for example, if we discuss the CSV reader, will you show CSV reader today?
Yes.
Yes, so in CSV reader, just please, Sebastian mentioned this, when you read a CSV, as a second argument to CSV reader, you need to pass a type of a target table. This is exactly because of this, that when you read a CSV, you need to tell CSV reader what kind of specific table type you want, because this will affect, and this should be driven, but how do you want to use the data later? Yes.
Okay.
Just one idea, is there a default?
Yes, so there is a default, but okay, so this default is in CSV reader, you mean, right? So in CSV reader, is a type called CSV file, which is a default, and it is also a table. But this CSV file default has very limited functionality because it's optimized against just getting kind of a reference to this CSV file. So for example, will be not mutable. So you can, okay, read it, you can view it, but you cannot mutate this object. If you want to mutate it, then you say, okay, I want a data frame, because once you want to start mutating data, you need to decide on how do you want to use it. But here, default would be CSV file, and then you write CSV file and your file name, and then you have a generic table, but with very limited functionality, because CSV package says, I don't know what you want to do it with later. So you need then to decide yourself.
So this is not materialize it, but just put reference.
No, it's reading it, but it's
put reference to the.
No. It's reading it,
okay.
But it doesn't allow. That doesn't support mutation, because if you want to, so it's reading, so it's materializing it, but in the most efficient way from the perspective of reading the data, not accessing or mutating the data later. So this is, so we could say that this format is optimized for reading speed, but not for working with it later. Usually you want to do something later with this data, so probably this is optimizing for reading speed is not something that you that is most interesting for you.
Okay.
Yes, is it clear? Thank you.
Thanks for your declaration. Okay, so back to this REST API. What should be most important for you to remember is that if you use machine learning models for programming, is the same as you use any kinds of application. Your model is kinds of application. So what it mean? It means that all problems connected with DevOps, called developer operations, are nearly the same for MLOps workers. So MLOps workers try put your code, not only your model, but or your fully code to some production environments, because we want to use model, not just produce model. So this is this huge difference. And if someone don't understand still what is API, if you go to the restaurant, you have menu, and menu is perfect API. Yes, because you can take menu in different languages, and if you understand what is in menu, you don't ask about how it's prepare each dishes, but you know what you want to take. So this is very nice example of API and how it's work. Okay, so in our maybe I will put forward. In our case, we will produce something called client-server application, and I will try show you how these kinds of application could be very easily made in Julia languages. And of course, these kinds of application should give us possibility put HTTP request to a URL hosted by server system, and we should get response from this server. And it is typically like web browsers work, but in web browser cases you don't get response like JSON file or something complicated, but you just take something which web browser can read and can show you. It is just HTML code. So this is ordinary text, and this is how it's work. From in the request side, we need think about few parts. So this is endpoint URL address, which contain domain, which in our case is my domain. It should contain some port. It can contain path, and also in standard way, endpoint URL is it's just this parts, and it could contain also a query string. This query string is we see these kinds of query string many often if you just run Google and type anything, you will see that in URL is changes that you send information, but this kinds of URL. So this is connected with something called get methods, but for our case we will use a post method, but I will show these two kinds of HTTP methods, how to use them. And what is important that beyond of just information collected in the URL address, you have also sent HTTP headers, which mean we can think about this, that you send just some metadata to the server and you get metadata from the server. Of course, because they are headers, we don't see it exactly in our application. But of course, our application could have some read it and could have some do something depending on what kinds of meta information we get from it. And as I said, here is an example what kinds of information and what kind of JSON I must put to in our case for a machine learning model. So it is JSON connected with key of all features for our model, and each feature should has some value. This is ordinary row of data which we want to predict from our model. Okay, so in response, we have also kinds of other kinds of header, and these header are even more important than headers from request, because they gave us information that everything works correct, or maybe even not works correct, but they gave us information what is the response of our server. And in our case, we will see that our server will serve information about what kind of server we use, and that we send some information with JSON format in charset of UTF-8. And for example, here is one of example of response body that we have input of our features and values, and we get prediction of our model. Okay, here I put some codes. I think that they are just only codes not connected with Julia codes. So this is kinds of REST API example in Python with
HTTP status codes help because you can pass them. So
okay. So yes, this
can go wrong.
This HTTP one of the HTTP header information is titles code. It's gave us information if this code is 200, it means that everything is okay. But if we have 40 and something, we have information that we don't have access to our server. So something bad is for sender sites. And if the status code is by start with 50s, it means that something is bad in our server. So this is very important. This three information are very important because we know in which site we have problem. Yes. Okay. So as you see, it's not 1,000 line of codes to prepare a server and show a simply REST API application, because sometimes this is truly a few lines of codes and you get everything what you need. Why? Because in most examples you use some libraries like in Flask in Python. So you just need inform application what kinds of path you have, and if user get this path, you return for him this functionality in this function. And the same kinds of, as I said, in my opinion, you don't care about what kinds of programming language you choose, because you see that in this part of code, the code is nearly the same. The thinking about how I should prepare this code is nearly the same. Yes, so this is how it's work, and I will show you that that this is very, very easy in the case of Julia. Maybe this is what I want. Maybe just I will take this information and it will be fast, okay? And I will take your question, okay? So this picture perfectly show because we show you how to prepare model, how to get data, how to take feature importance. We show you how to optimize your hyperparameters, do many lines of codes. Of course, what is not good, what we show you is that we do it all in the Jupyter notebooks. It was Bogumi yesterday said why this is problem, but of course I just want to tell that please, if you work as data scientists, do not send your notebooks for MLOps workers. Send fully functionality codes connected with functions and pipeline, and this pipeline should contain all your transformation of data and preparation of model, and fully so your pipeline should contain fully stuff or you're working. Why? Because if you don't do this, it will be no possible put your work to the production system. And just this picture is for me is very nice because it shows where in this full picture of business where the preparation of model are. So you see that this is just this black box, and there are many other kinds of things that you must do. You can do this also by some automatization in many languages, like in Julia or in Python, but you must think, if you build your code, your machine learning code, your deep learning code, just remember that it will be works only if you prepare it with some good preparation of the thinking that it must be run on some other environment than just your laptop and than just your Julia notebook. Okay, so
Yeah,
yes.
So previous slide.
This one.
No, previous.
Previous, okay.
This one. Yes. So because essentially what I understand that you, Sebastian, are trying to say is the following. So of course you do not choose Julia because of its features of creation of REST APIs. You usually choose Julia because it's good for numeric computing or optimization or simulation, the things we have shown, for example, yesterday. But at some point you need to run this code. So not only write it, but run it on servers, in the cloud or wherever. Everyone has different needs. And kind of what Sebastian, if I understand you correctly, wants to say is those HTTP requests are not super sexy for machine learning developers, but it's important that there are such functionalities and you can use it. So like having to, for example, create a REST API in Julia is not a bottleneck for using Julia, because there are packages that also support all these, maybe not super sexy, but needed things that are later required so that you can run this code. So if you go back to the slide, so although this one. So although actually the ML code is the code, the thing you want to do, you need all these other things to run it in production. And those things are as easy to do in Julia as in Python or whatever different language. I'm commenting about this because very often people say that, Python is super good for all those other things. And this is true. But what we want to show you today is that Julia actually also covers this, which means that if you do your machine learning or advanced analytics of different kinds in Julia, you do not have to integrate it with Python, etc., because actually functionalities for doing all things around needed to run this code are also available.
Yes, exactly. Thank you. Okay, so let's see how it could looks like on some codes. Okay, so I will start. I know that you waiting a lot of time for it, but Okay, I maybe reach. Oh, maybe this will be better. It's small, I know. It's small for us, but it's bigger for our online participants. Okay. So.
Oh, it's still too small. Wait, just even larger. And maybe you could make yeah, exactly. It's larger. Maybe you can try a white background if it's possible. If not, then
Okay, so what is important that I remind you that how we start Julia environment and why I speak about this. It's of course convenient and easy, but it is important to showing something next step connected with Docker environments. So I will just typing that we must be here in our. We take this catalog from our GitHub account by clone it, all data, and add this catalog. We must be sure that we are in this catalog. We take the Julia project, and after that we can quickly check that by changing to the packages rip that we are in correct project, so we can run our the best environment for doing machine learning models. So we start Julia. Yeah, that's okay. Okay. Wait. It's not this. Okay, here. I must put it here. Using my Julia. And now I can run a notebook. Okay. Okay.
Can you also?
Yes. Okay, because I don't put information about directory, we have desktop as a first, but it doesn't matter. Okay, so okay.
The notebook exactly the directory where the project on, as it might not work for some people. So
No, it's from standard, from main category, main directory, so it will be work. I check. Okay, so what we can do in this notebook, as I said, we take housing data sets and we use it to generate a machine learning model. In my case, it will be not so fascination, but how we can get this model. I want just take ordinary model with some pipeline to standardize data, because in my case, for me, interesting is not how good Gini you can get from this model, or how it's great, but how it works. Okay, so we have several features, and we want to predict the median value of our target features. And we want to use a JSON-based web service. Our web service will be connected with a Geni library in Julia. So let's see how we can do it. Okay, I just verify if, as Przemek said, if everything is correct. I know that I'm in correct project, so I use load CSV library and data frames library. And as Bogumił said, here we can see that we take a path for our catalog, for our data, and type of what kind of type of data frames of table we will use. This is not mistake and not something wrong that I just connect data catalog with a file, because you should, in your code, you should use functionality for connecting a path for your folder. Why? Because in Windows and in Mac or Linux system, you can have difference between slash and backslash. So in this case, it will be work in all systems. So you are independent of the system. So this is kinds of funny, tricky functionality, but it's very important, for example, for production environment, because if you assume that you work on the Windows, you can get you can get information that your program not works. Why? Because there is no slash and this is just backslash. So this is the reason why I show it. Okay, so we have a simple data frame, and here I put some metrics for our data to get. Okay, houses. I don't run our. So I read our data to the data frame. I just show a few rows because, and this is very nice in Julia that you can use typical thinking that in matrix, which are data frames, in matrix, the beginning is rows and next elements is columns. So this is typical how we describe the matrix. Okay, so we describe this information about our data frames and data. What is most important for me is that this column number of missing is everywhere 0. What it mean? It means that I could neglect any transformation for none values. But there is, if you have this kinds of data for your machine learning model, this also could be a trap, because in this case, when you prepare these kinds of models with in the case when each row will be contain none value. So my question could be what you do and how your server will work and what kind of response you get if your request will contain a none value. The same we can thinking about categorical columns. Of course, if we have integer float columns, it is easy because we put always a value, some continuous value, a real number. But the question could be, if I have some categorical levels on some feature, how my server will or model will explain and what it how it will work if I put some value that is not contained in my data. Yes, this is for rethink what can be, because if you put your data to the data frames and do some calculation, you don't think about even it, because you have data, so you prepare everything for this part of data. But of course, in real life examples, data can change and everything can change. And the word of change is the most important things in DevOps thinking and MLOps thinking. So this is just kinds of problem you should take to thinking about production environment. Okay, so we can take some names, because taking names is just for easy way to get names of and maybe construct of our JSON. Okay, so for model preparation, I will use MLJ library. Why? Because it's easy. And I will use it not exactly for model, but I will use it because I want quickly take some pipelines in my application. So I will get just standardized, and there will be just one step in my pipeline. It will be pre-processing and it will be standardized each column to the standard value. So what we mean by standardized, I think that everyone knows that we correct it on the mean value and divide it by standard deviation. Okay, so at present, I will do not take any kinds of deformation of data to the test and train set. Why? Because it doesn't matter for us here. But of course, this is one also step which you should do on your machine learning codes. So I just take information about what is my table of data, what is my target, and take machine as Łukasz showed us for our pre-processing, and we will fit our value of mean and standardize and transform our full data frame. Okay, so we see that in quick way we can get a data frame which is transformed, and in easy way by fitted parameters we can check okay, sorry for that. We can check what kinds of parameters our machine is used to get a correct answer. Okay, so okay, the most important why I need some pipeline is not that I won't show you how to use this standardization for data frame, but for me it is important that if in our case in production, what will be in the request of our application, it will be connected not with transformed data, which are put it to the model. Okay. But in our case, our raw data will be connected not with transformed data, but with but it will be connected with our data at the beginning. So if we do any transformation of our data, this is what I mean by putting code to the functions and functionality. It means that all transformation for our data must be put it to some kinds of functions. Why? Because if they are not in functions, they are just in few letters on a few rows in our notebook, developers will not know what transformation you want to do with your data. And if you don't this transformation, your raw data will be not transformed to the data which you use to produce machine learning model. And what it means? It means that if your model will give you a prediction, it will be perfectly bad because it will be not for these kinds of values what you want. And if not, in the bad case, you will just get information that your model is your data are not correct sometimes. Okay, so we have a pipeline, and what is very important is that I used MLJ libraries not because it's easy, but because you can save your pipelines to the file. Okay, so why I need save my pipelines to the file? I must do something that I can, because if I can save my pipeline to the file, I can load it on any other computers. In other case, there is no possible change and take all transformation and put it to the other server computers and other kinds of stuff. Okay, so I can check that if I load my machine from file, and this is one step that it's very important here, is that you should restore your load machine, because if you don't do this, you will not be able to transform your data. So we can check easily that if I load this pipeline from file, I could apply it easily in the any data frame which I want. Okay, so now I prepare data for modeling. So I just divide my matrix of my features and my target value, and I will use just ordinary linear regression model, not for all features, to get some simplified kinds of models. I shouldn't say it, but in this step, I don't care if the coefficients are okay or not. This was work for Bartek, and he told you when it has sense or when it doesn't have sense. Use some features. Okay, so to test it, I will take test first 2 rows and find information that I can predict, not just one row, but any number of rows. And because here is not always good to write all features we need, you can check easily that it will be always also works if you just run a full of your data frame. So you don't need care this model take this feature which is important for this model for you. Okay, so I can prepare to the test, I can prepare some dictionary with some values. Why I prepare dictionary with some values? Because if I will send information by JSON to the my server, I will load it by some functionality as a dictionary. So this is the reason why I checked how dictionary with this value can be predicted from my model, and it's easy if you apply a data frame to this dictionary, you can get answer, and this is displays what I talk about. Why before I take a value like 29, 25, etc. Why I get prediction minus 260? It is correct or not? They are raw data, kinds of, but prediction is not so good. Why? Because what I missed? I missed standardization of data. Yes? So I missed pipeline case. So if you missed your transformation of your data, I can say the bad scenario is it works, but prediction you get is totally wrong, but it's work as it should. So what we can do is that we at the beginning we should transform our data to the correct values for the model, not correct values for the beginning, but for the model, and after that everything is okay. So because we have few minutes and I will show you how to save the model, you can think how I can, if I have model like some object in my memory, in my notebooks, how I can do something with this model that I want This model run on Przemek computer, on Bogusław computer, on Bartek computer, on your computer, on your computer. What I should do? I cannot take Jupyter Notebook and put it on your computer and run everything. Why? Because it's nonsense. If data contain millions of rows and if I need some special access to some databases, it is not possible reproduce my code in any other kinds of computers and any kinds of environment. So this is the reason why I need save my model. So in Python, we can say that in Python, you can dump or save any kinds of object in Python you want. And here in Julia, we will say save our model to the JSON format. So this is very, very easy to get this. And we can check that if we load this object, I will call it object, but of course it's my Python thinking, and I know that it's perfectly something different than object, but it doesn't matter. We know what I want to say. Okay, so you see that I can load my file and get prediction. What it means? It means that this is the easiest way how I can, because if I put this file to the where I can put this file to the any GitHub environment, and you can load this model, and you can load to your Julia environments and use it as you want. Okay, so this is, of course, in a real production environment, you will not save model as a file, but you will probably use more something like databases for models. Like in Python and in production environments, we frequently use something called ML flow databases, which you can save your not only your models, but on also your parameters or hyperparameters and or your experiments. Okay, this is just showing that this part I will omit, but because it is nothing new, but just showing you that if you take other kinds of models, you can also save this model to the JSON file. So it isn't that just one class of models you can save and other kinds of models you cannot save. But just remember that this standardization which we made as a pipeline, we also save it as a model. Okay. Okay. So, okay, this I must. Okay, I must run just one things. Just one model. Because I use a Jupyter Notebook, I made one imported mistakes. You see these mistakes is that I use in the next cells, I use something which is defined before. So if I don't run it, it is not defined and I cannot use it. So so this is what you must be careful if you used this kinds of stuff. Okay, so I define tester of data. I put it to the transformation and predict to the get information if it is correct. I put this example to the JSON file. I checked if I write it, it will be okay, and I can see it as a just ordinary bash more functionality. Okay, so let's see how it will be work as for a web server. In the case of web server, this situation is easy. As I show you that this kinds of code for Python and for Node.js, JavaScript, you also use some libraries, and you see that our things how to build a server is very easy. We just show what kinds of root we need, and we just put what kind of information we want return. If we need just simple JSON, we can use just dictionary and put it and transform it to the JSON. But if we need use a get method, we can get information from this method by connected with URL address by get payload functionality. So this get payload functionality will change our URL address to the dictionary, and we change this dictionary to the JSON file. So if what is important is that the app functionality starts my server, but because we are in Jupyter Notebook, we should use this async variables to the true, because if not, it will be run and stop, and all notebook will be stopped for using. How I can so if I run it, I get information that my web server was starting on the localhost address in the port 8000. How I can check if it's work correctly? Of course, I can go to the address, but sorry. And oh, okay, this is what I can see in my web browser, because web browser show me the text. This is of course JSON text, but it's also visible in the web browser. But I can use URL functionality. This is bash functionality, so I just put it as URL and address of the server, and I get fully information and response. I see what kinds of response I get, and how it's work with this, because I put here method get, and I load all the information from address. If I change this address, I should get new kinds of JSON file. So if I put that key is value 1, for example, some value, key value 2 or key value 3 will be some other kinds of functionality, other kinds of value. If I send this, I load everything to some dictionary, and I send it as a JSON. So this is how I can put information and get information to my Julia code. But of course, get methods is not so good for sending a huge dictionary, because you don't want to type everything in the address URL. Okay, so for short information, it is very good to send everything by get. Of course, what we don't send by get, it's login and password. Okay, why? Because you can see it on the web browser and in the URL. So and it is not with ****. So don't do it. Okay, in the Julia, I can because CURL is bash kinds of elements. I can use exactly Julia code to get this response of my server, and this is this work as the same. So I put get methods with this address, and if status of the response is 200, it means that everything is okay, and I print what is body of the response. So this is very, very easy how it's work. You can find the code using by PyCall how to write and using Julia connected with Python. You can, because this is a server for independent of the language you use for a client, you can write any client you want in any languages you want. It's must just send a request and get response. And this is very, very nice. So this is, clients are language independent. Okay, so now let's take all the elements, but because what will be difference between this simple web server than our web server with models? There will be no such huge difference. One difference is that at the beginning, I will load my pipeline and my model from file. Yes, why? Because I want to use it. When I want to use it, I want take everything from, because it will be more method post and I will send JSON. I will load everything to the dictionary by method JSON payload. And if I have it as a dictionary, I will do just the same steps as before. So I load everything. I put my dictionary to the data frame. I change this data frame by transform operation to the standardization value. And if I have this, I can put it to the predict. Yes. And I prepare everything by dictionary when I collect information, what I put to the request and what should be response. Okay, very this kinds of methodology was not introduced. Przemek, you don't show try catch, yes, on your first. Yes. So why we should use try catch here? Because if you use try catch, you have you are sure that if something gets wrong with your data, your system still will be working. Yes. If not, it will be give you some exceptions, but everything will be down. It is not good, write a code which could be breakdown. Yes. So this is the next. This is just one piece of code, but this piece of code show you that even if you are a data scientist, you should write your code thinking about what will happen if if my data or I do something wrong, because I'm not only prepare a machine learning model but it must be prepared and ready for environment, production environment. So I will run this server. I know that I don't have time, but I should just try show you quickly. So I have this JSON file, and I load it as a part of my CURL request, and I will take information to the header that my request will be connected with JSON file, and I will put here. So I will send one row of data, and I get perfect prediction for the server. Okay, maybe so we see that it's work. At the end, I want just show you that everything is on our GitHub, that you have Docker directory when you can find Docker file. What is important with this Docker file is that why we need Docker file. For what? Because as you see here, it is easy load your model and everything from file, but it's work only if you have Julia environments in your computer. Now we have situation that we want to run 1,000 servers with our application. It is not possible takes a seat and install 1,000 Julia environments in each server. Yes, if it is virtual server and or stationary server, it is impossible. Why? Because it take too much time. So we need some possibility to automatize this process, and one of the things that you can use is exactly Docker system. In Docker system, you just take information, what kind of image and the base you want to use, and this is easy because you use Julia image, so you can find all images in the Docker Hub. So this is like in Python, you have PyPy libraries, and you can load everything. In Julia, you have a main repository when you load your packages. In Docker, you have also main repository when you can load any kinds of application you want, any kinds of environment. So you load just Julia, you copy all files to your Docker image, to your Docker image, and what is important is here. It is why I show you again how to run Julia at the beginning. So you use Julia command with flag E, and you start packages and activate your environment and instantiate every packages. And after that, this exposes information that you want, that Docker will send information about port which the server is connected. And after that, you want activate your environments, and by include, you run your application. Application is easy because it's just Julia codes with exactly the same codes which we have on our Jupyter notebook. And this is, and to show you how it's work, I will not do it on the, because I don't have a time, I will not do it on the web server exactly, but I have one of instance where I do it. So I put a new instance of server, I install Docker. It is one thing I must do, and by git clone, I copy all the program of the server, and I run Docker image. Yes, so this is what I must do. This process can also be automatized by any Jenkins kinds of programs, and this is how it's work. So at the end, I know what is end. Thank you, Przemek. At the end, I will just show you quickly. Sorry for that. Oh, here, and I will share just this for. Yes. Okay, just because. Okay, I'm in the clients directory, and I have clients in the Julia file. So if I run it, I send a request as I show, and I get response and information that everything works. This client has real IP number and of my machine, virtual machine, and everything is work perfect. So this is how production can work for you.
That's the IP of the server that you have on the network.
Yes. Yes. And now, of course, there are a few steps more, but I just can say that now you can take Terraform, and you can use it is called infrastructure as a service. Yes, and you can, by code, you can produce thousands of servers, and if you need 1,000, you produce 1,000, but if you need million, you produce million. Of course, the cost are cost on the cloud, but it is easy. If you have this Docker image, it is easy run everything you want.